There are a couple ways we can store carbohydrates in our body, and this next section is going to take a look at that. The most optimal form of carbohydrate storage is going to come in carbohydrate form. So we take carbohydrates that we eat, break it down into sugar, and then we're going to convert it back into something that's kind of like starch. That is called glycogen. So the storage form of carbohydrate is called glycogen, and we're going to put glycogen either in our liver or in our muscles. And it's noteworthy that we can only store about 1,600 calories of glycogen. So 1,600 calories of carbohydrates is about 400 grams of carbohydrates, and about 300 of these will store in the muscles, about 100 of them will store in the liver. Outside of that, we're pretty much just going to convert carbohydrates into fat once we reach that limit. That 400 grams or the 1,600 calories, that may sound like a lot, but compared to the amount of protein and fat that you can store, it's a pretty small amount. So for muscle protein, even though it's not a great energy source, you can store about 30,000 calories worth of protein, and somebody who is very muscular is going to be able to store much, much more. And I'm looking at the very bottom of the screen just so you have that as a reference. And then if you go right above that to adipose tissue, which is just our fat tissue, we can store about 80,000 calories worth of that. That's for an average person. 80,000 calories lasts a long, long time. When you compare that to 1,600, you have a much greater energy storage from those two things. The problem is that carbohydrate is important for specific things that fat and protein do not do quite as effectively. Heard of carbohydrate loading before, and what that is, it's just a nutrition or dietary manipulation or adjustment to maximize the amount of glycogen that we can store in our muscles and our liver. Now, it's commonly used by lots of athletes, but it specifically benefits athletes who specialize in endurance type activities, and they'll do this in order to avoid hitting the wall, which is an energy crash when you run out of carbohydrates at a later stage in an event or an exercise. So basically the main benefit of something like carbohydrate loading is just that it delays the amount of time that it takes to reach fatigue. And so the amount of effectiveness of this is kind of limited. If you were able during exercise to just eat carbohydrates when you start to run a little bit low in blood sugar, it would have the same effect, if not a better effect, than carbohydrate loading would prior to an event. So what do carbohydrates do? This section is going to look a little bit more specifically at the functions of carbohydrates. The main roles of carbohydrates are going to be providing a certain type of energy. They're going to aid in digestion, and they're going to help prevent the breakdown of muscle protein. Once again, carbohydrates are either sugar or fiber. Sugar, they're going to provide us with, again, a certain type of energy. They're responsible for the release and regulation of blood sugar levels, and they also provide energy specifically for the brain. Fiber helps more so with digestion. It's going to push things through the GI tract, and fiber can help to get rid of cholesterol, and that's specifically soluble fiber. Soluble fiber helps get rid of blood cholesterol. So carbohydrates play a role in providing a certain type of energy for the body. That energy from an exercise standpoint is primarily for anaerobic exercise, which is going to be more intense, faster, stronger exercise. It's also going to give fuel to the brain. So carbohydrates are the primary source of energy for higher intensity physical activity. It's important to understand that we are always going to be burning carbohydrates, fats, and proteins. But the reliance on these things is going to vary depending on what it is that we're doing, mainly between carbohydrates and fats, as long as we have a good dietary balance. Hopefully we're not burning too much protein. But we're always going to be burning carbs, fats, and proteins. When the intensity of an exercise increases, we're going to burn more carbohydrates. And as the exercise intensity decreases and gets closer to a walk type pace, that's where we're going to use and burn more fat. As you can see here, as we increase the intensity of the exercise and we go closer to a full all-out effort with whatever it is that we're doing, we're going to burn more of our calories from carbohydrates, less from fat, and as the intensity decreases, more of the calories that we burn are going to come from fat. So remember we said that we're always going to be burning carbohydrates, fats, and proteins. Remember that. I'm going to tie this into a little story that I have my own running experiences through a race called the Bear 100-mile race. It's a 100-mile foot race that starts in eastern Utah, northeastern Utah, and crosses the Utah-Idaho border to finish in Bear Lake, Idaho. It takes somewhere around 24 hours for most people to finish this type of an event. There's a big variation, but around 24 hours, that's about the average. And I was having a really good run. I was staying pretty consistent, running pretty smooth. I think I moved into about 20th place, and around mile 60 to 65, 70, I started to feel a little bit rough. I just had a really hard time getting going. My pace slowed quite a bit, and I attributed it to just having a low point from just putting lots and lots of miles under my belt up until then. My friend who was running alongside me to provide support, at some point during this time, he gave me some of his GU energy gels, which are just a really concentrated source of sugar. He gave those to me, I popped those in, and almost immediately, maybe a minute or two after I ate a couple of them, I started to perk up a little bit. And I would get about 20-30 minutes of reasonable running, nothing crazy, but running. I'd get that in, then go to another low point. He'd give me some more of those chews, I'd pop them in, feel good for another 20-30 minutes, and keep that cycle going until I was able to get across the finish line, finish around 15th place, and just crack under 24 hours. Now the point of that is, while I was doing that run, I'm moving at a very slow pace. It's a run, sure, but we're not going too fast. So the intensity is pretty mild. But the thing that was limiting was the carbohydrates. And that's mainly because of the amount of carbohydrates that we store. It's so low. We can burn lots and lots and lots of fat, but as we're burning some carbohydrates, even if we're burning just a small amount of it, we're going to run out of carbohydrates before we run out of fat. So carbohydrates are usually going to be the limiting factor for energy levels when we're doing physical activity, regardless of the intensity. We talked about how carbohydrates fuel the brain, and it's easy to think because the brain is kind of small that we're not going to require a lot of carbohydrates to actually function, to cause the brain to function optimally. However, even though the brain makes up only about 2% of the size of the human body, the energy needs of the brain make up 20% of our total calorie demands, that are basically our calorie intake. So carbohydrates are needed because they're going to fuel brain activity. An adequate carbohydrate intake is linked to memory, attention, and focus. Memory, attention, and focus. Now, the brain is able to use ketones, which is going to come from fat, if we're in a state of ketosis. But otherwise, if we're not in ketosis, carbohydrates are going to be the most effective fuel source for the brain. If we do not have an adequate carbohydrate intake, then our body is going to break down protein. So adequate carbohydrates are going to spare our protein so that it can stay as our muscles and our tissues, which is very, very, very important. So first of all, we want to do this because protein is a very inefficient fuel source. And then secondly, because it's going to require the breakdown of our muscle tissue. Now, if we're in a state of ketosis, which is hard to get to, but it's very doable, if we're in a state of ketosis, then inadequate carbohydrate intake isn't as important. But in all other circumstances, for 99% of the population in the United States, they need adequate carbohydrate intake in order to prevent muscle breakdown and protein loss. Now, how about fiber? Fiber is a carbohydrate. Do we use fiber as energy? To understand fiber, we have to break it down into the two different types. We have soluble and then we have insoluble. And what that means, soluble versus insoluble. Soluble means that it's able to dissolve in water. So if we consume soluble fiber, it's going to turn into something that's kind of mushy in our GI tract. Insoluble fiber, that does not break down. That stays kind of rock solid. It's incapable of being dissolved. So insoluble fiber, it maintains its hard form, doesn't break down. It's going to push things through the GI tract. It just moves things right along. Soluble fiber, because it turns to mush, it's going to soften things in our GI tract. And then its second role is that it's going to reduce cholesterol levels. So, nowhere do we talk about how it plays a role in energy. Fiber is more so linked to overall health and that it promotes digestion. And then soluble fiber, it's going to reduce cholesterol levels. Fiber itself is not going to provide us with any energy. We're going to wrap this up by talking about carbohydrate food sources. Take some time to run through this activity. On this page, try to find out which carbohydrates are good, which are bad, and which aren't even carbohydrates. So, from left to right and then top to bottom, we have quinoa, we have sliced turkey, oatmeal, white rice, and then we have instant oatmeal. Bottom row on the left side, we have fruits, then celery, then corn, chocolate milk, cookie, and then we have white pasta with Alfredo sauce. So take a minute to go over this. You can pause this now and figure out which of these foods is either A, a good carb, B, a bad carb, or C, not a carbohydrate at all. All right, let's come back and run through them. Quinoa, good. Turkey, no, not a carbohydrate. Oatmeal, good. White rice, kind of a bad. Brown rice would be much better. Instant oatmeal, kind of a bad. Regular oatmeal, steel cut oats, that would be better. Fruits, good carbs. Celery has some carbohydrates, but really it's a non-starchy vegetable, so it's not a carb. Corn, good carb. Milk, it's a good carb. Chocolate milk, not so much. Lots of added sugar to it. Makes it not so good. Cookie, bad carb. White pasta, bad carb. There are different groups of carbohydrates that have different characteristics. You can mainly break these down into 5 different groups. First of all, the starchy ones. You have the grains and the starchy vegetables. The grains are things like breads, pastas, cereals, bagels. Starchy vegetables are very similar to grains, but they're vegetables. And that includes things like potatoes, carrots, beets, squash, corn. Those are starchy vegetables. Then the next group is dairy, milk, yogurt, some cheeses. Then you have the sugar carbohydrates. And dairy is kind of a sugar carbohydrate too, but it's kind of in its own class at the same time. For the sugar carbohydrates, you have fruits. Those are the good carbohydrates. And then you have sweets, bad carbohydrates. Sodas, candies, syrups, desserts, those are the sweets. Going back to my plate, really there's going to be three groups of foods that have carbohydrates. You have the grains, the fruits, and the dairy. You could include the vegetables as well, but because the starchy vegetables are solely grains, I think it's easier just to throw them in over there. But those are the main food groups that have carbohydrates. Again, good carbohydrates are not necessarily complex carbohydrates, and bad carbs are not necessarily simple carbs. Good carbs are generally unprocessed. They're going to have more fiber, minerals, vitamins. They tend to have a lower glycemic index, and they fill us up a lot more quickly. Bad carbs, this is what gives carbohydrates a bad rap. These are the ones that are high in sugar or refined grains. They don't have as many nutrients, and they pretty much just load us up without filling us up. So we can eat lots of them, and they don't make us feel full, whereas the good carbs with the fiber and the water, those are going to make us feel full and satisfied, and help us to stop eating when it's time to stop. And the part that I would like to end on is kind of making this full circle and bringing back carbohydrates and their role on overall health. Carbohydrates get a bad rap because of the bad types of carbohydrates, the processed carbohydrates. And the processed carbohydrates, they are going to create something that's known as inflammation. It's not just carbohydrates, but processed carbohydrates are probably the main contributor to this. Processed meats will do this as well. Excess alcohol intake will have this effect. But processed food, especially added sugars or carbohydrates, is going to create inflammation. And most of the chronic diseases that are present today are linked to inflammation. The root cause is inflammation. This inflammation is going to damage the cells in our organs, and that includes our brain. And over time, this inflammation is going to break down the organs and break down more parts of our body to the point where we develop severe problems with certain organs, which leads to chronic long-term disease. So that's all for this lecture. There's going to be one more. We're going to talk about protein. Stay tuned. More to come soon.